had. They thought that since the paper mills that made the paper, the big, huge rolls of newsprint that the Tribune uses, were on the Great Lakes in Quebec, that they could just float them down here and put them in right here from the river. Unfortunately, those big barges are too big for this part of the river. The river isn't deep enough. So they thought, well, we'll just dredge the river and make it deeper, but that's not something you really want to do to the Chicago River because it was so heavily polluted for so many years that below about 6 inches or so of dirt and clay and silt that's fallen since the river's been cleaner is a real toxic mess. And if you start dredging that up, you're asking kind of for a whole universe of environmental problems you don't want to deal with. So the door is a great idea, just didn't quite work out this time. So this can be a good time if you want to go use the bathroom or go get a drink or some coffee down at the bar. I'm not going to point out any new buildings for a little while. I'm just going to tell a story or two about Chicago. As I've already told you, I'm kind of an engineering nerd, and so I'm really interested in all the bridges in Chicago. We're going to go under 23 different bridges. All of our bridges still open, and Chicago has more movable bridges than any other city in the world. And the reason for that is, as I explained earlier, our river is our harbor, since we don't have a harbor like Boston or New York has. And so the river was very busy with all this river traffic, so they needed the bridges to go up really quickly for all the ships to go through. But then the bridges had to go down really quickly so city road traffic could start traveling again. And they tried several different designs of bridges to try and solve this problem, and the design they came up with is a design they use for all the bridges that we're going to see today on the tour. You probably noticed that all these bridges open in the middle, and you can think of each side of the bridge as a giant seesaw or teeter-totter, like the children's playground toy, or the children's playground toy. And one side of the teeter-totter is the bridge deck that extends out over the river and carries the road. And then there's a big axle that it all turns around, and on the other side of that axle is a huge concrete weight that balances the weight of the bridge deck on the other side. So just like a teeter-totter, where you've got a kid at each end that weighs about the same and it's just very finely balanced, that's how each side of these big bridges is. It's just very finely balanced, and the balance is so finely calibrated that to open one of these bridges you only need about a 100 horsepower motor, which is the size of the engine you'd find in a really small economy car. 100 horsepower isn't very powerful, but that's how fine the balance is on these bridges. So you can, because it sort of works like you can imagine if you have a teeter-totter that's very finely balanced, and then one person comes to the end and just pushes it a little bit, it's very easy to make the other end spring up, and that's sort of how these bridges work. The balance is so fine that even when they do something like repaint the bridge and add the weight of paint, they have to weigh the paint they put on the bridge and then add more weight to that big concrete counterweight on the other side. Chicago, you know, we're with a second city, we have sort of an inferiority complex sometimes. So I don't think people like the name or the idea of seesaw bridges, because that would just make us feel more insecure. So they came up with two French terms for the name of these bridges. The first term is trunnion, which is the French word for that big axle that it all turns around. And then the other word is bascule, which is the